A few weeks ago, a new post has been published on Hacker News about an on-demand AWS-based Minecraft hosting. And this post was this almost free serverless on-demand Minecraft server in AWS, which explains how is it possible to host a Minecraft server in a very low budget. And the main idea was to use AWS DNS services and just check the log of the DNS. And if you can detect if somebody tries to access the service based on the DNS log, then a Lambda function created the real container, the Minecraft container in this case, and it was possible to connect to the container because this magic just started the container. And well, this is DNS based, so it's not very easy to use outside of AWS, but I found another comment in the same thread that it can be very easily to create in any server environment. The only requirement is a TCP reverse proxy. So let's say somebody tries to connect on one port to this reverse proxy, and before it forwards all of the traffic to a new one, which is very simple things to implement, it can execute a command or start a container, and after that just forward all of the traffic to one specific port. So I implemented this one and tried out, and it worked very well. So in my implementation, it was possible to define this port, the destination port, and a command to start and stop the container. Well, the other requirement was just to have some timeout. So when all of the connections are closed, then this container can be stopped again, just to make it cheaper, similar to the AWS solution. But the problem that sometimes this actor just pinged the port to check if it's up. So it's definitely something what we need to check. So we need to wait a few minutes after any ping before shutting down this container. But during a conversation, one of my colleagues showed me an other approach. And yeah, this is the original Hacker News discussion with the implementation, which explains how does it work exactly and where are the, so this is the public DNS, this is the route 53, and you can see that there is some watchdog and everything in place. But the other one is a ready-to-use Minecraft server, which uses a different approach. It's using nocd, and it can auto-pause the container, which is a very interesting approach. So what's happening here is that the nocd is a very nice daemon, and usually it's used to open secret ports. So usually the interface, the Ethernet interface, receives any packet before the firewall, if it's a OS level firewall. And by default, the firewall just rejects the connections. But there is this nocd, and you can send specific packets or patterns. For example, ping the port 100, 101, and 102 in 15 seconds. And if this pattern identified that this daemon can open the firewall and just enable to go in and use the service. So this approach uses exactly the same. So this is just one port. So there is no requirement for specific pattern here. And if there is an incoming connection, it will execute this resume, which is another command from here. And it's nothing more, just the magic seek continue signal. So in Linux console, we can just execute the seek. So usually the it's almost the same. Okay, it's not exactly the same. That when we do Control Z for a running application, then a 6-stop signal has been sent to the process, which means that it won't be scheduled on the processor. The memory, it's still used, but eventually it can be swapped out because it's not under active usage. So that's a very interesting usage. I don't need anymore to stop and start something. It's enough to send these kill signals. So I try to implement it as well. So I have this ad hoc application, okay, where I have a few parameters. I have the listening port. This is the default port where it listens. I have a destination, which is another port, and when somebody connects to this one, it will proxy all of the TCP connections to this port. But in the meantime, if there is at least one connection, then it will select a PID and send this the stop and continue signals. So let's try to do this one. I need, first of all, an HTTP server. So maybe this is the easiest way to do. So I have the server. I can ping it. Yeah, it's working. I have the response. And let's start this one. So by default, it will use this one as the destination. And let's say I would like to stop all of the Python processes. And let's try to connect to this one. Yeah, it works, but when the connection is closed, you can see that suspended the HTTP server, so I couldn't access it anymore directly, right? It seems to be running, but under the hood it stopped. But if I connect to the port of this daemon, then still I can access it, right? Because it just sends a continue signal to the original process just to wake it up. And after my connection is closed, it's stopped again. So it's a very easy approach to use more servers. What I have on paper or based on my resources. So what we did here is just creating, so here I had this ad hoc daemon, and I had this port here, and the Python application. And after any connection, when all of the connections were closed, then a 6-stop signal has been sent to the Python, which means that I didn't use any CPU. The memory was the memory was not freed, but eventually it can be swapped out. So it worked well, and it's not just for Minecraft, right? It can be used for any on-demand databases, for example. Sometimes I need cloud databases just to test something, but I don't need to run it all the time. I have a server, and I can just have an on-demand database, which is used only when it really required. And one other thing which can be done is just use it from Kubernetes. So for example, in Minecraft server, this is something like this. So you need 2 containers. One container can be any database, Minecraft, or anything else, just a good old database. And you can add an additional container. This is a sidecar container, where I have this application which listens on another port and forwards everything to the original port and will stop and start the bits, right? So that's all what you need. And the secret sauce, the magic, the share process namespace equals true. What is it? So usually in Kubernetes, there are pods, not containers. And most of the time, one pod is one container, but sometimes one pod can contain multiple containers. So what we did here is just we created one Minecraft DB anything, the real service as a container inside a pod. but we can put any additional container at the same pod. But the question is that what are shared between the pods? So the network usually is the same, so they can see each other. The volumes usually are not saved, not shared by default, so you need a volume if you would like to see something common. And by default, the PID namespace is not shared. So if there is a PID1 here, you couldn't see it from here. That's a different PID namespace. But if you define this share process namespace, then you can see exactly the same processes from both of the containers. So it's possible to send signals from here to here, which can be database, Minecraft, anything. Actually, the Minecraft is not the best example because Minecraft tries to render the word based on ticks. And if it detects that some tick took a lot of time, it has different kind of tricky warnings which should be turned off. But for a simple database, it can work very easily and very well. So yeah, this is the link to the Nocti based approach, and this is the quick summary that what about the different solutions. So first of all, it should be detected that somebody would like to use the service itself. It can be detected based on the DNS log. I found it quite complex. In AWS, it can be easy to check the daemon, but if you have DNS daemon somewhere else, it can be tricky. The TCP reverse proxy, we can say it's more complex, but it's very easy to detect if the server is used or not. The NOC daemon can detect when somebody would like to connect in, but there is no easy way to check if it's still the connection is still used. So you need some scheduled job to check if the users are still there, or you can stop the process eventually. And you can do, when you detect it, when the incoming action, you can do anything. You can create a new serverless container. You can create a new container, or just execute a command. This is I also tried this one. Just execute a Docker Compose app command and done. Or the easiest way with this sidecar approach is just sending a signal to stop the process, and later it can be continued, which can make it easier to manage processes which are not used very frequently or just used sometimes. I have a few self-hosted bookmark service or read it later service, which is not very frequently used. So it's very easy to manage in this way because you don't need to spend CPU time on these services unless you would like to use at the same moment.